Welcome to Audio Abet, your gateway to the fascinating world of data science and machine learning. Whether you're a seasoned tech enthusiast, a curious beginner, or someone exploring the impact of AI in everyday life, this is the podcast for you. Join us as we dive deep into groundbreaking technologies, share insights from industry leaders, and simplify the complex concepts shaping the future of innovation.
Deep dive.
Sounds exciting.
Today we're tackling a topic that I know you're super interested in, transitioning into data science from a non-technical background.
A very popular topic these days.
Absolutely. And, you sent over some fascinating research articles, academic papers really focusing on AutoML. I can't wait to unpack it all with you.
Looking forward to it.
There's even a surprising connection to evolutionary algorithms,
Yeah.
which we'll get to a bit later. But are you ready to dive in?
Absolutely. Let's explore.
Perfect. One of the first things that jumped out at me from automated machine learning.pdf is this idea that AutoML can automate so many steps in the machine learning process. It really seems like it's all about streamlining things, making machine learning more efficient.
Yeah.
And I imagine that's particularly appealing coming from a non-coding background.
Yeah, for sure. What's interesting is that traditional machine learning, it can involve a lot of, manual tweaking and experimentation. It's almost like an art form in a way. And AutoML really aims to bring more structure and systemization to this whole process.
So instead of needing to be a coding wizard, you can leverage AutoML to kind of handle some of that heavy lifting.
Precisely.
That's pretty awesome.
And this has huge implications, especially when you consider the scarcity and cost of machine learning experts. AutoML can make these really powerful techniques accessible to, a much wider range of individuals and organizations.
That makes a lot of sense. And speaking of accessibility, the paper also emphasizes the importance of open source AutoML systems. What's the significance of that?
Oh, open source is critical for democratizing machine learning. It allows anyone, regardless of their resources or technical background, to experiment with and benefit from AutoML. So it's really, it's like opening up this whole new world of possibilities.
Now get this. The paper even claims that AutoML can sometimes outperform humans on certain tasks. Is that really possible?
Yeah, it's true. And, in certain benchmark tests, AutoML has actually demonstrated superior performance compared to human experts. However, it's really important to understand that human expertise remains essential.
So it's not about machines taking over completely.
Not at all. Human intelligence is still crucial for things like defining the problem, selecting the right metrics for success, and most importantly, interpreting the results and making informed decisions based on that output. AutoML is a powerful tool, but it's a tool that needs human guidance.
Okay, so let's unpack some of the technical details a bit. Automated machine learning.pdf dives into something called hyperparameter optimization, or HPO. To be honest, it sounded a little intimidating at first.
Yeah, it can sound a bit complex, but the concept itself is actually quite intuitive. Imagine you're tuning a radio to find the perfect station. Each knob that you adjust represents a hyperparameter, and each adjustment influences the quality of the sound.
So finding the right settings for all those knobs is key to getting the best performance.
Exactly. Hyperparameters control the behavior of machine learning algorithms, and HPO is the process of finding the optimal settings for these hyperparameters to maximize the performance of your model. For example, in a deep learning model, one crucial hyperparameter is the learning rate, which controls how quickly the model adjusts its parameters during training. Finding the sweet spot for the learning rate can make a huge difference in the model's accuracy and efficiency.
That's a really helpful analogy. Now, I always love those unexpected connections. The term foundation models popped up in generativeareport.pdf. How do those relate to what we're discussing about AutoML?
That's a great question. Foundation models are essentially massive AI models that are trained on enormous data sets, and they can be adapted for various tasks, almost like a Swiss Army knife of AI. While they're not strictly part of AutoML, they can be integrated into AutoML systems to enhance their capabilities.
So it's like having a powerful engine under the hood that AutoML can leverage to achieve even better results.
You could say that. Foundation models provide a strong base upon which AutoML can build and optimize specific machine learning models.
All right, now for the surprise I promised. Evolutionary algorithms. The automated machine learning.pdf mentions them as part of HPO. And honestly, it sounds a bit like something out of Jurassic Park.
Yeah, it's a fun connection. Evolutionary algorithms are inspired by natural selection. Imagine a population of potential solutions. In this case, different sets of hyperparameters. And the algorithm evolves better solutions over time by combining and mutating the best ones, mimicking the survival of the fittest concept.
So it's like breeding a super algorithm by selecting and combining the most successful traits.
Exactly. It's a very clever way to automate the often tedious process of hyperparameter optimization. And it's particularly useful for complex machine learning models, where, manually searching for optimal hyperparameters would be practically impossible.
That's amazing. Is this actually used in real-world AutoML tools?
Absolutely. One example is TPOT, which is an open-source AutoML tool that uses this evolutionary approach for HPO. TPOT can automatically explore different machine learning pipelines and hyperparameter configurations, helping you find the best model for your specific problem without requiring extensive manual tuning.
It really highlights the power of AutoML to democratize machine learning. You don't need to be a coding expert or have years of experience to build powerful predictive models.
That's the most exciting part. AutoML is breaking down those barriers, making it possible for people from all backgrounds to harness the power of AI and machine learning. And as you're transitioning into data science, this is a powerful trend to be aware of.
It's almost like having an intelligent assistant that's constantly learning and evolving alongside you.
Yeah, that's a great analogy. And this brings us back to the importance of those core data science skills we discussed earlier.
Yeah.
Even with AutoML taking care of the technical complexities, having a solid foundation in those core data science skills is still crucial. And since you're coming from a non-technical background, I recommend prioritizing a few key areas.
Let's hear them. I'm sure our listener is eager to know.
Okay, firstly, focus on understanding the fundamentals of machine learning, even without diving deep into coding. This involves grasping the core concepts, different types of algorithms, and how they work at a high level. It's like understanding the why behind the algorithms, which is crucial for making informed decisions when using AutoML.
So it's more about understanding the logic and the possibilities, rather than writing code from scratch.
Exactly. Think of it as being the architect who designs the blueprint. Even if you're not the one laying the bricks, AutoML can handle the construction, but you need to provide the vision and direction.
That makes a lot of sense. What else should our listener focus on?
Data visualization and communication are incredibly important. Being able to present your findings in a clear and compelling way. Telling a story with data is a skill that sets you apart. Even with AutoML doing the heavy lifting, you need to be able to explain the results to stakeholders and make data-driven decisions.
So even though the algorithms are doing the complex calculations, you still need to be the translator bridging the gap between the data and the decision makers.
Precisely. And finally, don't underestimate the value of your own domain expertise. Coming from a non-technical background, you bring a unique perspective and understanding of a particular field. And this can be invaluable in data science, as it allows you to frame the right questions, interpret the results within a specific context, and identify potential applications that others might miss.
It's like having a secret weapon, a deep understanding of a field that can unlock hidden insights from the data.
You could say that. Your domain expertise combined with AutoML can be a powerful combination, allowing you to tackle complex problems and drive innovation in your field.
This is all tying back to AutoML, right?
Yeah.
Because even though it can handle a lot of the technical work, you'll be much more effective if you have this solid foundation in data science.
Exactly. AutoML empowers you to focus on the higher-level aspects of data science. But you need that foundational knowledge to leverage its full potential. It's like having a high-performance car. You still need to know how to drive to get the most out of it. It's a perfect analogy. You wouldn't want to be stuck in a Ferrari without knowing how to handle the gears.
Exactly. And speaking of handling things effectively, let's shift gears for a moment and talk about something I found particularly interesting, the connection between AutoML and those evolutionary algorithms we touched on earlier.
Yeah, that connection is really at the heart of how AutoML works, especially when it comes to hyperparameter optimization. Remember how we talked about those knobs on a machine, those hyperparameters that need to be fine-tuned? Well, evolutionary algorithms can actually automate that entire process.
So instead of us manually tweaking those knobs, we can let the algorithm do the searching.
Exactly. It's a brilliant application of a concept borrowed from nature. The algorithm starts with a population of potential solutions, different sets of hyperparameter values, and then it evaluates the performance of each solution. And just like in natural selection, the best performing solutions are selected to reproduce.
Okay, so the algorithm is essentially mimicking that survival of the fittest concept. But in this case, it's the fittest set of hyperparameters that survives.
Precisely. And the reproduction process involves combining elements from the best solutions and introducing small random mutations to create new, potentially even better solutions. This process is repeated over multiple generations, gradually evolving a population of hyperparameters that lead to the best overall model performance.
So instead of us trying to find the needle in a haystack, we've got this algorithm that's constantly searching and evolving to find that optimal configuration for us.
That's a great way to put it. And the beauty of it is that this process can happen automatically without us having to manually test every possible combination of hyperparameters, which would be an incredibly time-consuming, if not impossible, task.
And this is where those open source tools like TPOT come into play, right? They're using this evolutionary approach to make AutoML accessible and effective for everyone.
Exactly. TPOT is a great example of how evolutionary algorithms are being implemented in real-world AutoML systems. It allows users to simply input their data and define their objective, and the algorithm takes care of the rest, automatically exploring different model pipelines and hyperparameter configurations to find the best solution.
It really highlights the power of AutoML to democratize machine learning. You don't need to be a coding expert or have years of experience to build powerful predictive models.
That's the most exciting part. AutoML is breaking down those barriers, making it possible for people from all backgrounds to harness the power of AI and machine learning. And as you're transitioning into data science, this is a powerful trend to be aware of.
It's almost like having an intelligent assistant that's constantly learning and evolving alongside you.
That's a great analogy. And this brings us back to the importance of those core data science skills we discussed earlier. Even with AutoML taking care of the technical complexities, understanding the fundamentals of machine learning, being able to visualize and communicate your findings, and leveraging your domain expertise will make you a much more effective data scientist.
It's like having all the right tools in your toolbox, but you still need to know how to use them effectively.
Precisely. AutoML is a powerful tool, but it's not a magic solution. It's a tool that needs to be guided and interpreted by human intelligence. Your understanding of data science principles, combined with your domain knowledge, will enable you to make informed decisions, interpret the results generated by AutoML, and ultimately derive valuable insights from your data.
So it's not about replacing human intelligence, but rather augmenting it with the power of automation.
Absolutely. And that's a recurring theme we see in many areas of technology today. It's not about machines taking over. It's about humans and machines working together to achieve things that wouldn't be possible alone.
This has been incredibly insightful. We've covered so much ground, from the basics of AutoML to that fascinating world of evolutionary algorithms and the importance of those core data science skills. But before we wrap up, I want to leave you with a thought-provoking question to ponder.
I'm all ears.
Given the rapid advancements in AutoML and its increasing accessibility, how do you envision the role of the data scientist evolving in the future?
That's a great question to consider. As AutoML becomes more sophisticated and capable of handling increasingly complex tasks, I believe the role of the data scientist will shift towards more strategic and creative aspects.
What do you mean by strategic and creative?
I see data scientists becoming more like conductors of an orchestra, guiding the AutoML process, fine-tuning its performance, and interpreting the results within a broader context. They'll be responsible for defining the right problems to solve, framing those problems in a way that AutoML can understand, and ensuring that the generated results are aligned with the overall business objectives.
So it's less about the technical execution and more about that big picture thinking and the ability to connect the dots between data and real-world impact.
Exactly. Data scientists will need to be skilled storytellers, able to translate complex data insights into actionable recommendations for stakeholders. They'll also need to be adept at identifying potential biases in the data and ensuring that the AI systems they build are ethical and responsible.
So a blend of technical expertise, strategic thinking, and ethical awareness will be the defining traits of the data scientist of the future.
Absolutely. And the most successful data scientists will be those who can embrace the power of AutoML while simultaneously honing their own unique skills and expertise.
It sounds like the future of data science is going to be a fascinating blend of human ingenuity and powerful automation.
Absolutely. It's an exciting time to be entering this field, and the possibilities are truly limitless.
I couldn't agree more. Now, before we wrap up this incredible deep dive, I want to circle back to the listener's original goal: transitioning into data science from a non-technical background. Given everything we've discussed, what advice would you give to someone embarking on this journey?
Well, first and foremost, I would say embrace your unique background and perspective. Don't view your non-technical background as a disadvantage, but rather as a strength. The diverse experiences and skills that you bring to the table can be incredibly valuable in data science.
So it's not just about learning the technical skills, but also about leveraging the knowledge and insights that you've gained from your previous experiences.
Exactly. Your domain expertise, your understanding of a specific industry or field can be a powerful asset. It allows you to ask the right questions, frame problems in a meaningful way, and interpret data insights within a relevant context.
It's like having a secret decoder ring that unlocks the hidden messages within the data.
I love that analogy. And building on that, I would encourage you to actively seek out opportunities to learn and grow. There are so many amazing resources available online and offline, from online courses and boot camps to data science communities and meetups. Don't be afraid to experiment, network, and connect with others in the field.
It's all about being a lifelong learner, constantly expanding your knowledge and skills. And with tools like AutoML becoming more accessible, the barriers to entry are lower than ever before.
Absolutely. AutoML can be a fantastic tool for beginners, allowing you to get hands-on experience with machine learning without needing to be a coding expert. But remember, it's just one tool in your arsenal. Continue to develop your understanding of the core data science principles, your ability to communicate effectively, and your own unique domain expertise.
It sounds like the key to success in data science is a combination of technical skills, domain knowledge, and a passion for continuous learning.
I couldn't have said it better myself. And as you embark on this journey, remember to stay curious, embrace challenges, and never stop exploring the fascinating world of data.
This has been an incredible deep dive filled with insights and inspiration. For anyone looking to transition into the exciting world of data science, thank you so much for sharing your expertise with us today.
It was my pleasure. I'm always excited to talk about data science and its potential to transform the world.
And to our listener, thank you for joining us on this personalized journey. Remember, this is just the beginning. Keep learning, keep exploring, and who knows, maybe someday you'll be the one guiding the next generation of data scientists.
I can't wait to see what the future holds.
That's a wrap for today's deep dive. Until next time, keep diving deep and keep those questions coming.